Hi dear friends, good morning to one and all. Dear friends, in the last part of the video, we have discussed classification of polymers and we came to know that there are different criteria to classify the polymers into different types such as source of the polymer, structure of the polymer, thermal response of the polymer and the physical properties of the polymer. So dear friends, in the previous part we have discussed the classification of polymers based upon various criteria in detail with their example also. Dear friends, now in this part of the video we are going to talk about one of the important property or the characteristic of polymer, and that is a molecular weight, or we simply called as molecular mass of the polymer. It's very important to define or to express the molecular weight of the polymer by means of a particular method, because these polymers are very large and the complex molecule, and that's why whenever we will talk about their molecular mass, this molecular mass will be also a very large, and that's why it's very important to define the molecular mass of the polymer, because this molecular mass of the polymer decides the physical properties of the polymers, or it decides the various physical properties of the polymer. And that's why here in this part of the video now we are going to talk about how we can express, how we can define the molecular mass of the polymer, and what are the different methods by which we will be able to express, we will be able to define the molecular mass of the polymer. Dear friends, if we will talk about the molecular mass of the polymer, then you will come to that the polymer or the molar mass of the polymer controls the various physical properties. Now, just already I told you, it means that if the molecular mass is going to vary, its physical property will also vary. Definitely that physical properties may be physical constant, it may be the density like this. But whenever we are going to talk about the molecular mass, then this molecular mass decide the physical properties of the polymer molecule. However, the molecular weight of polymer is not one unique value. It is not a unique value. It means that whenever we want to define, because for example, suppose we will talk about the one of the chemical compound, and that is NaOH. This NaOH is the basic compound that we call it as the sodium hydroxide. And suppose we are interested to calculate the molecular mass of this sodium hydroxide, then definitely this is having a 40. So the molecular weight of the molecular mass of the sodium hydroxide is 40. This is the unique value. This is a unique value. But whenever we will talk about the molecular weight or the molecular mass of the polymer, then the molecular mass of the polymer is not a unique value. Definitely the polymer will have the very large molecular weight or the molecular mass, but that value will not be unique value. Large in the suppose it is having the 50,000, so this 50,000 is the unique value, isn't it? But this 50,000 here, any polymer will not have this unique value, it will have the range. So here, rather than this, polymer will have a distribution of molecular weight or the molecular mass. Means, for example, some molecules will have the molecular mass of 50,000, some may have 50,000 and 500, 50,000 and 500. Some molecules may be having the 51,000, some molecules may be having 41,000 and 500. So this is the range in the sense, suppose that is 52, that is 52,000, and this is the distribution of molecular mass of the polymers in a particular mixture, because the number of molecules or the number of molecules present in the polymer is not fixed. That's why rather than a unique value, it will have the distribution of molecular weight. This is the very important thing regarding with the molecular mass of the polymer, and here hence it's very important, it becomes very important to express the molecular mass of the given polymer. And there are different ways to calculate or to express the average molar mass of the polymer on the basis of how the molecular mass is expressed. So what are these methods? Particularly these methods, just like the classification of polymer, what criteria is taken into consideration, that criteria will decide the name of the or the type method that we are going to use in this part to express the molecular mass of the polymer. The first one is called like the number average molar mass. Number average molar mass, because in this method the number of molecules are taken into consideration. That's why this method is called as the number average molar mass. So definitely we are going to discuss each and every one detail one by one. Second method is called as the weight average molar mass. So this method based upon the weight of the polymer. That's why it is called as the weight average molar mass. So this method, number average, is sensitive to number of molecules rather than their size, and here this method depends upon the weight of the polymers rather than their number. The third method is more interesting, and we are using this method in laboratory to calculate the molecular mass of the given polymer, and this method is called like viscosity average molar mass. This method is based upon the viscosity of polymer. So whenever the viscosity of polymer is taken into consideration to express the molar mass, to determine the molar mass, then the method is called like the viscosity average molar mass. Dear friends, we will talk about the first method, and this is a number average molar mass. If we will talk about the number average molar mass, then this method, that as already I told you, this method depends upon the number of molecules rather than size of the molecules. So this method, this property is sensitive to the only number of molecules present, and it is not depending upon the size of any particle present in the mixture. So this number average molar mass depends upon the number of molecules present in the mixture, and it is not depending on the size of any particle present in the mixture. And for such properties, the most relevant average molar mass is simply calculated as the total weight of polymer divided by the number of polymer molecules. So whatever total weight of the polymer is divided by the number of molecules. So number of molecules is taken into consideration, and this average molar mass follows the conventional definition for the mean value or any statistical quantity. It means that the way is to calculate the mean value. Mean value, that is total sum of total observation divided by total number of observation, and in polymer science it is simply called like the number average molar mass. So here we are going to talk about the average of number of molecules in order to express the number average molar mass. That's why it is called like the number average molar mass. How we can express this and how we can calculate for this purpose? Here we will have the number of molecules. For example, we will consider here one polymer sample in which the number of particles or the number of molecules are indicated by N1, N2, N3. So these are the number of molecules having molar mass. Here molar, dear friends, molar mass is indicated by means of pen W1, but these are not the molar mass. I think it should be indicated by means of pen. It should be indicated by means of pen M1, their molar mass, M2, this is the molar mass, and M3. So this is the mistake in the textbook. So this, let's consider the polymer sample in which the number of molecules are N1, N2, N3, having the molar mass M1, M2 and M3. Average molar mass in this case is given by means of this average molar mass indicated by number average molar mass is given by the Mn bar. It is taken as the addition of number of molecules into its molecular mass plus number of molecules N2 into its molar mass M2, number of molecules of the third type N3 into its mass. Similarly, we can add more if there is more number of the molecules, more number of type of molecules, and divide by the number of molecules n1, n2, n3. This is just as the summation of ni mi divided by summation of ni. I is the variable that depends upon the number of molecules. Mi is the again mass of the respective molecules, and this is simply the summation of xi into mi. It's very important because this is xi is the mole fraction of a polymer having molecular weight mi. Because dear friends, this much quantity, how n1 divided by n1 plus n2 plus n3, it becomes x1. Then n2 divided by again n1 plus n2 plus 3, it becomes what? It becomes x2. And n3 divided by this n1 plus n2, it becomes x3. So this is the mole fraction, number of moles of particular species divided by the sum of number of moles of all the molecules. That is called, that we call it as the mole fraction. Similarly, this ni divided by ni, it means that this is the value of xi, summation of xi, x1, x2, x3. That's why this number average molar mass can be also written as summation of xi into mi. Dear friends, now if we look at the relationship between number of molecules and the weight of the molecule, you know very well, number of molecule indicated by, or number of moles, I will say the number of moles rather than this number of moles suppose indicated by means of n, then this number is always number of moles, I will say the number of moles actually rather than the number of molecules. Number of mole, it is what? Weight. So this weight divided by molecular weight. So weight divided by molecular weight is the number of moles. It means that from this W can be written as W is equal to n into m, and that's why Wi here written as the ni into mi, because already I told you ni is the ratio of W, means the weight of the molecule divided by molecular mass of the molecules. And if we will replace this, what? If we will replace this ni by means of an Wi divided by mi, I hope you will be able to see this. If we will put, instead of this ni, if we will put Wi upon mi, then definitely this, that is this mi and this mi will get cancelled, and we will have only Wi. And divide by what? Divide by summation of ni, but ni will be replaced by Wi divided by mi. So here we will have to the denominator as summation of Wi upon mi. Similarly, we will get this equation for the number average molar mass as this can be expressed in terms of, that is weight also, and it can be also expressed in terms of number of molecules also, as this number of molecules and their molecular mass. So these are the ways by which we will be able to express, we will be able to define the number average molar mass. Here if we will talk about the meanings of the different terms, then Wi is the weight of ith polymer having the molecular mass mi, and number average molar mass is determined by the various method like osmotic pressure or N group titration or the colligative properties. So this is the way by which we will be able to express, we will be able to calculate the molecular mass of the polymer in terms of number average molar mass. So dear friends, in this part of the video we tried to explain one of the method to express the molecular mass of the polymer called as number average molar mass. Similarly, in the next part of the video, we will talk about the weight average molar mass and the viscosity average molar mass of the given polymer. Thank you. Thank you very much.